Have you ever been in love so deep there's no way out? I wish I could explain your eyes and how the sound of your voice gives me butterflies. How your smile makes my heart skip a beat. How every time I'm with you I feel so complete. So complete. You are the light when there is no sun. You are the rainbow when the rain is done. You are the wind that whistles my name. You are the love when the world's the same. You are the star that twinkles in the night. You are the moon that shines so bright. You are the wind that whistles my name. You are the love when the world's the same. Have you ever met someone you feel like he's the one? Have you ever loved so much, so much?
You and I go separate ways, 'cause lately I don't feel the way that I used to, that I used to, that I used to.
Hello, welcome everyone to the stream where we will be watching Starship Flight 12, and as well we'll be going through what Starship has changed over the last year with new pad infrastructure, new basically, I'm not going to go into technical terms, new fueling structure, and as well the Starship itself. It's changed, the booster's changed, everything's changed. It's more efficient, it's more reliable. Well, hopefully it'll be more reliable in this launch, and we'll see the outcomes and incomes of new technology. Now, as you can see, we are on the Starship page of SpaceX. Now, you think to me that Starship, it sounds like a myth. It sounds like you don't know what it is, or you have no clue what it is. My camera's not on. I've just noticed that. I'm gonna get my camera on. Give me a second. Camera's not coming on. Nah, ha 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 ha. That's not great. Not the first thing that happened to this today. Come on. Okay, that's a massive. Why is that so big? Okay. Okay. No, come on. Okay. That's concerning. Okay, my camera's on. Welcome back, guys. It's me, Ken. With everything going on this week, no, not this week, with Starship, it's a lot's changed, and honestly, I think you'll enjoy it. If you want to subscribe to my YouTube channel, it's in the bio in Twitch, and if you're on YouTube and you want to check out my Twitch channel, it will be in the bio. So double for double. Anyway, we're going to start with the Starship overview. Now, this is the newer Starship. This has all been updated. Its height was, as you can see, it's now 124 meters, or 487 meters, feet. Feet. That's the that's the height. Diameter is, it's a bit higher this time, and it's 9 meters, and payload capacity is 100 tons plus that. With Starship itself, as you can see, it's a Starship. It's very, very nice and rustic designed. The black side is the heat shield, where when it hits our atmosphere, it can burn its way through without being destroyed. You know, it's like it's a shield around the rocket. That's what shielding is. Yep, you got your basically propellant capacity is fuel basically. So in a car, let's say you drive a car, you've got a fuel tank. Instead of a fuel tank, it's in Starship and Stealth, and it's literally called Starship. So it will store repellent inside, and it'll basically it's like starting a car. When the engine starts, it ignites in the fuel in the engine, and it goes. Instead of it's like a reverse. Basically, we don't use any engine. We use fuel. It goes down into a compressor, and then it comes out, and we have an igniter, and it flames up, and it's like a jet of fire, but it's more pressurized and more able to go up instead of. Anyway, we're not going to get into that. With everything, we have the booster, which came up next. Yep, super heavy. This is the new part. It's the new hot staging ring. So we used to have a hot staging ring beforehand. They used to separate between Starship and booster. Now it's integrated into the booster, so it's more reliable, and it's now not going to need 3 stages. We've now got 2 stages only, and that's the booster and Starship. Could be good, could be bad. I'm not looking at the camera properly. I'm sorry. That's my problem. Capacity, yep, 3,600 tons of fuel can be stored basically inside the super heavy rocket. As you can see, the engines this time are on the outside, so you can see the engines without having a cover over them. It's quite a cool concept. This is the Raptor engines. Now they use 33 Raptor engines on the yes, it says 33 there. It says 33 Raptor engines. Can't really get remote, but it says 33 Raptor engines use the subwater coolant methane. Yes, we're not going to talk about what it uses because you'll get bored of me very quickly. Raptor engines, they're vacuum engines, so you have Raptor engine and Raptor vacuum engines. So the vacuum engines are for space, when we want to go through space, and the Raptor engines are for landing and liftoff. Falcon 9 Merlin engines for Starship are powered by 63 Raptor engines. These are the Raptor engines. They are the newer version, so Raptor 3 engines, more modified, more sophisticated, and this is the last version. So this is the best version they have. Okay. As you can see, this is the Starship capability program. This is a futuristic design, so please do be aware it's not real yet. As you can see, there's a video. This is Starship itself. As you can see, it's going to have windows, hopefully, eventually. It has chopsticks to land and launch off. You'll see them soon. The hot staging ring is going to disappear. It's got the new one. So this is an old video, as you can see. The launch mount's changed as well. So that's gone. That launch mount is completely changed. So you won't see that. Here's the actual engines. They all rotate, get ready, so you'll see them in a video of rotation. This is delivery to payload, so this will store about 100, they would say 100 Starlink satellites. Starlink sat is another entire thing. If you want, instead of on your phone, you basically, if you're on a contract, it's a little bit harder because you have to pay, but in Starlink, it's a lot easier because it just comes from satellite instead of cell towers. So if the cell towers go down in the UK or wherever you live, then you're screwed. But because this uses satellite technology, it never goes down. It's kind of cool, interesting, but you can get it on your phone now. But you need to have T-Mobile or any other thing that's linked to Starlink. As you can see, it looks very nice, and it has worked. The payload has worked. This is the moon thing, moon conception. Mission 2028 is coming up. Basically, we're going to land on the moon, and we're going to try to colonize the moon. The Starship. It's gonna be quite interesting. Some stuff, but not everything. Anything else do I need to know about? Oh yes, mission to Mars. That's the last one. So, 2030, they will land on the moon, land on Mars, but humans won't be on the Mars the first time. They will be sent with with SpaceX, not SpaceX, with Tesla robots. They will land and they will build our habitat for us, and then we'll come in through 3 to 4 years later, and then humans will colonize the Mars surface. So there's some time on that, but that will happen hopefully eventually, and we can see the outcomes and incomes of space travel, so we can go to Mars and the moon eventually. Okay, rapid usability. Now, we've had some downfalls. Okay, we've had quite a few downfalls with SpaceX as with some um we basic reusability. But in the future, in the recent times, it's been really good. We've had, yes, our booster landing on the chopsticks. That was insane. We never really um seen it before. It was the first time, I think, Flight 5 was the first time we saw it land on the chopsticks. Apparently, it was if it was literally about to go wrong and it could launch into go straight to the tower, but they managed to correct it just before it hit the tower. So it was a very close call. But they landed on the tower. They landed on the chopsticks. These things they literally landed these onto this, and it was in the mid. It was mid-air landed. Pretty insane. Um, and number 6 happened, and then 7, 8 failed, 9 failed, 10 failed, 11 failed, and now we've got 12. So we hope for the best. This is on orbit, basically refueling at space with another ship, like plane to cargo plane or jet plane to jet plane refueling. You happen in the air all the time. Now we're going to do it in space for the first time, and this is how it's going to be demonstrated. These are the pin connectors and fueling ports, so they will connect to each other, as you can see. And basically the fueling process begins, and then it will end when they disconnect. It's quite interesting. This is Starbase, as you can see. So they basically build Starship here, inside here and outside in these bigger, taller units. This is Star City, Starship, not Star, Star City, as it's called. But basically, they've built an entire city, and it's expanded a little bit more now. And more of this. So this is the launch pad. I'll show in a minute. Has changed dramatically. A lot of this has changed, by the way. This is an old picture. Okay, so this is Star Factory itself. Inside here, they make Starship itself, the nose cones, and then they stack them up in these taller bays. Same as the booster. Make the booster in here, and then stack them all up together so they're barrel sections. So it goes up and up. We can talk about that more when it comes around to it. Okay, so remember we have a countdown here. It's pretty cool. I haven't seen that before. Yeah, the Starship, we don't need that right now. Missions. They have done over 652 missions. This is counting for Starlink launches and for Dragon launches. Dragon launches are the International Space Station. They deliver humans back and from Cape Canaveral or Texas, Florida. It's quite cool. Yep, and total landings. So they land boosters. It's quite cool because you never think of it, but they do land these boosters. And then we have to reflying, so the boosters are reflown again. So actually, it's a recycled process. It's a lot more efficient than NASA used to do, and the Russians, and the Chinese. Yep, it's a lot. Learn about more. Oh, we've already seen that. No. Okay. making history. So they now have Dragon that will dock to the International Station and back, sending humans from Earth to the ISS, or the International Space Station. Really, really conceptual. Falcon makes history, so it's the first Falcon rocket that will land and then come back. Dragon Research Space Station, yep, research. First ever landing, so this is the first ever booster landing on the pad. Drone ship landing, so yeah, they have now a drone ship in the sea that they land boosters on, so it's pretty cooler. This is the first reflight of a booster. First flight, so this is the first heavy rocket they've built. SpaceX. Dragon docking with the ISS. Yeah, I'm talking about that. So this is the reusability process. So their boosters will land on the pads without any like humans. This is all programmed. It's insane, you know. So this is them landing it. This is the Starship. This is not the Star. This is the Starlink missions they have. So the Starlink, the rocket will launch. It will ascend. It will separate. So this will be the second stage. The first stage. The first stage will flip. It will fire its engines. It will flip. It will come down. It will re-entry. The engines are built for re-entry, by the way, so they don't destroy it. Then air dam. So basically, they try to lean the ship so it follows the air, so it can actually go with the air down. And then it will fire up its engines, and then it will land with the legs. Second stage will come up, and it will go up all the way to where it needs to get to. Then it will separate its fairings, so the fairings will come off, and then it's now exposed the satellite, and then it comes to where it needs to release the satellite. It will release the satellite, and the second stage will disappear, and then the satellite will go into space. Now, a landing is a bit more different. So yeah, we have a drone ship, and then same as it's basically the entire same, except from the booster. Instead, will basically go around, remove itself, come back down, and then try to balance itself down. So you can see a testing facility for Raptor engines, building facility for the rockets, and then Cape Canaveral for their space launch complex, Kennedy Space Center for their complex. They got a few launch complexes. Yep, they got another Vandenberg Space Force complex, and Texas Starship. Yeah, there's a few things. I don't know where the other thing is. Where's the other thing? We have it. So this is them stacking up Starship. This is the new Starship. As you can see, this is the new video. It's insane. Look at that. That's the new Starship. So this was a test, as you can see. So they're fueling up the Starship. So yeah, that's their Starlinks, satellites. All right. Okay, we are out of that. So now we go into. As you can see, it's been delayed by a few for the next few minutes. So please be aware that's happened. That's not my fault or anyone's fault. It just has happened. Unfortunately, that's the case. So please be aware of that. If you want to watch it, you can do by yourself. It is on SpaceX on Twitter or X. And then we have my favorite people I watch is NASA's spaceflight.com. This was to do with Falcon 9 launch. This is to do with Starship. So we're going to go into this and we're going to wait for that to start. If you want to ask me any questions, please do. Just don't be afraid to chat on Twitch. Thank you very much, or YouTube, in that latter. So we're just going to wait for them to. Right. With that, I'm now gonna wait for a while. Right, I'll make sure we get that sorted. Ow. Just get through. Thanks. Hmm. Sorry guys, this is just taking a while because I've got to wait for the thing to start. Only a few minutes, guys. Or girls. Oh, 43. Hang on, let me reload it because I might. There you go. We're live. Here we go. We're live and we're going ready. We're strong and we are brave stars. God, listen to that crap. Just need to listen to the. As we are seeing Mars at the moment. Let me check. Let me just check where we are with the fueling process at the moment. I'm on my phone, by the way. Okay, we're live. We're live. This is the trailer.
Alright, all operators on the count of 1. Flight directors go for launch. Stage separation. Sure, very simple. Booster has landed. Starship retract launch.
Hello,
Oh,
Star
43
people, and welcome to Starbase, Texas. It's currently 5:46 p.m. Central Time, and
Wow.
we are just over 43 minutes away from the first flight of SpaceX's
midnight.
next generation vehicle, Starship version 3. I'm Kate Tice, Senior Manager of Quality Systems Engineering.
And I'm Jake Berkowitz, a lead propulsion engineer. And today we're coming to you live from just outside the production floor at Star Factory, where the team's preparing for Starship's 12th test flight.
Yeah, it's been a few months since our last update, and in that time, the team has been working hard to completely redesign the entire rocket that you see there
And
from
launch
the
pad,
ground
look
up.
at it.
Yeah,
All
that's
new.
right, Kate. Starship version
Brand
3
new.
has undergone significant upgrades, taking everything we've learned from the previous 11 flights to make a vehicle capable of full and rapid reusability.
This includes everything from a new
Is this an
booster,
app
new
or
ship,
is-
new engines, to
Let me
a
check.
new launch pad,
I'm gonna
new
check the-
avionics, new software, and so much more. All of that hardware is just down the road at Pad 2, a little
I'm
over
gonna
a
check
mile and a
something
half
quickly.
away from Jake and myself. And in our viewing area outside on the lawn, Starbase employees are excited and already starting to gather to watch today's flight.
Yeah, and right behind us are 3 generations of Raptor engines, and today will be the first flight of the newest generation, Raptor V3. And the 33 Raptors on Super Heavy Booster combined to generate 18 million pounds of thrust. You can see them all there.
That's a lot.
It's a lot. And it makes
Those thrust
Starship
lines,
by
yeah.
far the most powerful rocket of all time. And for comparison, we have over twice the thrust of the Saturn V rocket that carried astronauts to the
I need to
moon.
know-
And then here, of course, you can see on ship, we have another 6 engines, and 3 of them feature the larger vacuum-optimized nozzles called RVACs. And as a member of the Raptor team, I can tell you that we're all incredibly excited to put V3 to the test today and demonstrate the capabilities of our most advanced engine.
I've got
And we'll get
a
into all the
live
exciting new
capture
details in
of
just a few
the
moments.
ship
Yeah, that excitement
itself
is
as well,
well
so I have
warranted,
2
Jake.
streams going.
Raptor and Starship V3 are designed to be foundational for the future of the
So
program.
I'll tell you when frost lines
They're designed
start.
to enable us to send
Means
payloads
you'll
and
see the-
eventually
you'll see the
people
fuel
all the
start to
way to
actually
the moon
go into
and
the ship.
Mars, ultimately helping us make life multiplanetary and extending the light of consciousness to the stars.
Yeah, and in the meantime, we're planning to put Starship to work shortly by launching bigger and more powerful Starlink version 3 satellites. These new satellites aim to substantially increase capacity in orbit, strengthen the network, and deliver an improved experience for customers on Earth. Starship will also carry our upcoming V2 Starlink mobile satellites, which are expected to provide direct 5G connectivity from space straight to mobile phones worldwide.
Now, as a reminder for all of you watching at home, what we're doing today is a test. Like we
Always a
mentioned
test.
earlier, we've redesigned the majority of this rocket and its systems. From the outside, for those of you that have tuned in before, it
Yeah.
might look pretty familiar, but beneath the surface, it's all new.
Yeah,
And
I
the
know.
primary objective today is to put it all together in a real live flight environment. In order to learn,
It's good
we got to
weather.
launch.
Yeah, and really, it's the data we're expecting to get back from today's flight that's going to bring us closer to
They are
making
cooling
Starship
down,
operational
so they're
and
chilling
unlocking
all
the
the
next
fuel lines and
generation
everything
of our
ready to
future
put
in
fuel into
space.
the rocket.
So no matter the outcome
So
of
you see
today's
all that
test
vapor,
flight,
that means they're chilling
excitement
everything.
is guaranteed.
Most definitely. And speaking of excitement, Dan Hewitt is in a
Oops,
pretty
Dan.
exciting place. He's
Always
stationed
Dan.
just
Dan's
outside of
always
the
the
Launch Control
guy.
Center, a couple floors above us. How's it going up there, Dan?
Kate, it
He's
couldn't
u-
be
he's
going
usually
better.
in the
We have a
control room.
blue sky outside. I'm beyond psyched. Hello,
That's the
everybody.
control room.
I'm
You
Dan
can see behind
Hewitt
him.
with
That's
SpaceX
the control room.
Communications. It's been far too long. Welcome back for another
Elon Musk will
Starship
be in there
launch.
probably.
Things are looking good.
Yeah.
We are counting down. We moved into our window a little
Is he
bit,
in there?
but we are looking good right now at this
Uh,
moment. Behind me, you see the flight control team. They're on console,
so.
looking at the rocket, the pad, the range, the weather, everything as we
see him.
count down to liftoff.
that's
We're
cool.
going to be getting into prop load in just a couple of minutes, and we are counting down to a liftoff at 6:30 p.m. Central Time.
That means
the weather
12:30
is great.
PM
We haven't had a
UK
blue
time.
sky all day. There you can see almost nothing but that. We were fighting some upper level winds a little bit earlier.
You can
That's
go if
why
you
we
want,
moved
and
into
then
our
come back
launch
stream
window. But the great
once we,
news is we
by
are
the time
looking go
12:30
for
hits.
launch.
that.
Also, we're monitoring the range, so air and sea space out in the Gulf and also in the Indian Ocean
I'll
and the
give you
other side of
notes
the
and
world.
updates
Not tracking
throughout,
any issues there.
this.
Now,
So I'll give you
today's
more
countdown
in-depth things,
functionally going to look
'cause
pretty
they
similar to
might go
most
over it,
people.
and
There's a
you might
couple of
not miss it.
differences in timing for some of those major milestones, like when we start loading propellant, when the diverter turns on and the water's flowing, when the engines start up.
Diverter
But
means
otherwise,
water
other than that,
is
all of
on
the
the launch
hardware
pad spraying,
brand new.
so it
New
doesn't
booster,
destroy
new
the launch pad
ship,
itself.
new engines, new pad. Let's nerd out. Let's dive right into it.
No doubt, I love that.
There it is in the pad. Say hello to Starship version
Yeah,
3.
that's
As
Starship
Kate
version.
noted, some of the outside might look familiar, but we've made extensive upgrades across every single system. Start with the big picture because Starship still very, very big. Just over 407
Yep.
feet tall, fully stacked, a little bit taller than version 2. With that extra stretch, we can carry even more propellant, but big rocket. The bottom half is our super heavy booster, and there are some pretty visible structural changes on the outside. We'll jump in. You've got version 3 on the left there, version 2 on the right. At the very top, we've changed from a one-time use hot stage adapter that used to pop off to one that's fully integrated for reusability. And Starship's Raptors are actually going to be igniting directly on top of the booster's fuel tank. The fuel tank pressure itself and then a non-structural layer of steel, it's what's protecting the top of that booster when we do hot stage separation. Moving down a little bit, we went from 4 grid fins to 3.
Yeah.
We made them 50% bigger and higher strength. Just a reminder, that's what booster is using to kind of steer itself as it's flying back for a catch. We're also now going to use those grid fins for lift and catch itself.
bigger ones, the new
we
ones.
zoom in a little bit, and you can see new catch points now on those grid fin structures. Moving inside the rocket, we redesigned the fuel transfer tube. This is the
Big.
really big tube inside the rocket that's
It's
moving
big.
all
Trust
of
me,
that
I
liquid
watched the video
methane
of them
down on
putting
the
it in.
Super Heavy's 33 Raptor engines.
That was a
It's going
video.
to help us flip faster, and we can now start up all of the engines simultaneously. This thing is big. It's about the size of a Falcon 9 first stage, which gives us the fun realization that we kind of put a rocket inside of our rocket. The very bottom of the booster looks very different.
they've-
You've got those new Raptor 3
they've
engines
taken off the
that
covers.
enabled us to delete the bulky heat shields, the engine shrouds that we had on the previous generation, and then all of the propulsion, avionics hardware for those engines are super tightly integrated now and protected by much slimmer shielding. Move on up, second stage. This version of Starship is designed to carry massive orbital payloads. We're talking up to 100 metric tons to Earth orbit, the Moon, and Mars. The biggest changes are pretty much all under the hood. We gave the propulsion system a clean sheet redesign, increased the propellant tank volume, and improved our reaction control system, our steering while we're on orbit. When we X-ray inside, the PEZ dispenser is now supercharged, a little bit of turbo, and that's going to allow us to increase the deploy speed for each of those satellites. Today, we're actually flying the heaviest payload we've ever carried on Starship, but eventually we're going to launch with up to 60 of those Starlink V3 satellites. Just below that, just below the payload bay and also down on the aft part of the ship, we've added new docking ports. That's going to enable us to link up in orbit between two Starships, do propellant transfer. We also modified that main connection point where we load propellants into the vehicle for those future prop transfer missions. So a lot of upgrades tip to tail on the rocket, but powering everything, the Raptor 3.
Yeah. They're powerful. More powerful than most rockets you'll ever get.
There they are, ripping in real time. These engines manufactured in Hawthorne, California, tested at our site up in McGregor. We redesigned their entire ignition system. We bumped up the thrust, so putting out more force, went from 230 to 250 tons force on those sea-level engines, 258 all the way up to 275 on the vacuum-optimized ones. When you look at all of the generations of Raptor lined up, all of those fiddly bits, the sensors, feed lines, controllers, everything that you were used to seeing around Raptor 1 and 2, a lot of those have either been deleted, best part is no port, or they're internally integrated and protected inside of the engine itself. That'll let us dramatically cut down on the weight of the engine, make it easier to manufacture because we are going to be mass producing these things. Now, we make these Raptors in Hawthorne. There's our Hawthorne manufacturing team. Get ready to see their engines fly in space for the very first time. Huge shout out to you guys. You're all wizards. Appreciate you getting us some vehicles on the pad today. But incredible amount of effort. World's best engineering team works here at SpaceX. Get this rocket to that pad ready to launch. And we've been trying to follow more of it and document some of it. And if you haven't seen it, check out our new docu-series, Starship.
Yep, they do. They have one of them. Here we go. Massive test site.
We really, built this rocket from scratch, but we've also built the pad from scratch. So it's all kinds of new systems. This will be the first time that we bring together the pad and vehicle pieces to make sure that they all work.
Right. So we'll come back to it. Starship. Yeah. We're gonna watch the 36. Stop there. I don't want the live stuff. World. This is the video. This is how they get in there.
Until about T-minus 4 minutes, a lot of stuff starts going down. T-minus 3 minutes, closing out the propellant load, so you're finishing out the liquid oxygen load and the liquid fuel load. T-minus 40 seconds, we stop interacting with the pad.
With the whole down clamps to hold it in place.
The vehicle's just on its own.
Current attention all V-19 operators, this is the final go no go poll for today's operations. Our main objective today is a 10-engine static fire.
Why 10 engines instead of all 33? This is the first V3 booster down at the pad right now, so there's a lot of stuff that can go wrong. And if we do have a bad day, it limits the scope of the issues that we can have.
This will be the highest chamber pressure we've ever seen on a vehicle at SpaceX, so definitely going to be a pretty spicy test today.
And then you're counting down from T-minus 40. T-minus 4 on is when my heart rate really starts to tick up.
Here we go.
And then we light the engines.
fuel started to go into the ship. Yeah, confirmed.
We are in Star Factory, and this is an almost 1 million square foot facility that we've built to enable that production of both ship and booster. Starship is a fully reusable rocket. It's 2 stages, so it has a ship, which is the upper stage, and a booster below it. The booster accelerates the ship to get it going towards orbit. The ship is what actually goes into orbit to take the people or the payload to wherever they're going. The sound of progress. The rivet guns and the sledgehammers. Less sledgehammers than there used to be. The story of Starship starts with the founding of SpaceX.
3, 2, 1.
Rather than starting with the vehicle that Elon envisioned needing to get people to the moon and Mars, he thought it would basically bankrupt the company. It wouldn't be possible. So you have to bite it off in small pieces.
Oh, Hopper. Yeah, that gets me. That's a...
And so those pieces, which at the time did not seem small at all, were Falcon 1, Falcon 9,
Yeah.
Dragon, both cargo and crew, Falcon Heavy.
Falcon Heavy is supersonic.
These were the building blocks that let us cut our teeth on learning how to do rockets. Not the way the aerospace industry had been doing it, but the way we needed to do it to end up here where we are today working on Starship. Version 3 is what I like to call the foundational design of Starship booster and the pad. That's going to give us the new capabilities we need to do the missions in front of us. It'll be the one that puts humans back on the moon. It'll be the ones that put the first blueprints and then city on Mars. Starship is giant, and that scale is not an accident. It's not to win some Guinness World Record prize, which we did for both the ship and the tower. It's because we need that size to do the things we dream of doing with it.
There we go.
Ship 39 is the first V3 rocket. This rocket is unlike anything anybody's ever done before. Version 3 is basically a clean sheet design of the ship. We essentially took a bunch of lessons from version 1 and version 2, and we took a step back and said, what were the things that were really problematic, either from a performance perspective or from a reliability perspective on the previous rockets? And then we directly addressed those with a variety of new designs. It can go up to orbit, it can stay on orbit for 48 hours, it can meet up with other ships, and it can do propellant transfers, which is really the core technology that you need to unlock Starship. Once you unlock that capability, the whole solar system is on your doorstep. And right now what we're doing is we're actually going through checkouts, so we're actually kind of bringing the rocket to life.
Mega Base
never
are the two
built
big
a ship
full
V3
buildings.
before and gotten it to this state of production. So we are going to have special things to this specific vehicle that are going to be odd, but there's also things about the architecture as a whole that we don't really know how to deal with because we've only done simulations, we've only built fluid models of how we think a ship V3 operates. Now we have the real deal next to us.
First priority is your safety, the second priority is make sure the vehicle's okay, and then we worry about executing to our schedule.
We're quite excited, we're quite anxious, but all things considered, we're pretty well prepared. We think that we'll have a good result.
We intentionally started Starship with the ship portion because it was so novel. We have done a reusable booster before with Falcon 9, and so it's at least a little bit better tread ground. I will say, I think the booster turned out to be a lot harder than we gave it credit for.
This is an entirely new rocket. This is the most ambitious vehicle design I have ever personally worked on, and it is a wild thing to see come to reality here. The version 1 flight test campaign really exemplifies the rapid integrated test style that we do in SpaceX engineering. It took us 5 flights from our first attempt, from Flight 1 to Flight 5, to successfully catch a booster, which was honestly mind-blowing. Flight 1 was able to get off the pad successfully. It proved that we could get this full system together, and we learned a lot from the eventual failure of the vehicle in that flight. We were able to put together a lot of improvements on the launch pad.
Yep.
And on the vehicle hardware design that led to much better success in Flight 2. We were able to make it with the booster to MECO. We were able to separate the ship, and we were able to begin boosting back towards the launch site. So we hit the next big milestone in the flight test campaign. On Flight 3, we were able to get all the way through our boost back burn. On Flight 4, we were able to do a successful water landing demonstration. And on Flight 5,
a big one,
we were able to come back to our launch site and successfully catch the vehicle with our chopsticks.
landed. First time.
To be able to go fly that and have complete mission success at that point of we got the payload to orbit and we landed that rocket was incredible. I'm getting goosebumps talking about it now. To get into a really exciting period of the vehicle test campaign here, putting the thing through its paces and making sure that everything we design works okay. Get all of the pieces of the system working together for the first time, and if we're going to learn anything from that, we'll learn it as quickly as we possibly can. Booster 19 is actually the second of the version 3 boosters that we've built. Booster 18 came before it. We had an unfortunate anomaly during our first test campaign of the Booster 18 vehicle. This is the first version 3 booster that we built, so this is Booster 18. This is really awesome because it's going to be our first full vehicle level operation and test with a version 3 vehicle. So the whole team's very excited about this. Sure hope it works.
Oh boy. This makes me
When we were pressing the nitrogen system, we had an explosion that took out the rocket, and thankfully we had designed that test to be safe. If something like that happened, we did not have propellants or reactive things on the vehicle, and so the test site incurred very little damage, and of course nobody was hurt in the incident.
Yeah, as part of testing, this is loud, so you learn to not be super skittish as you're walking around. So we have our booster here on site. We're going to be performing a cryo-proof. It's actually a really long day, so it's nominally planned to be a 12-hour overall prop load and offload. It's just a ton of propellant that we're putting on the vehicle, and we do a bunch of test cases throughout the whole day, so it's a long one.
Taking booster SM to cryo high fill proof.
Cryo-proof is the first time you actually put propellant onto the vehicle. The liquid propellant that we're putting on, it does get pretty cold, generally in the 80 Kelvin range. You want to test like you fly and fly like you test.
I want 70% proof percentage. Stay firm. And fuel interface is fully cryo now.
There is definitely nothing like a late night with your team in the control room. It's one of those milestones where you're like, wow, if I can load a rocket, this is amazing.
The FHT looks pretty stable. Let's go ahead and get booster configured for offload. Copy.
All of them get tested before they go onto the ship.
This is a Raptor 3. V3 is a high-performance boost engine. It's also designed to be reusable and highly reliable. We've learned a lot over the course of producing around 600 V2 engines. You can see the amount of simplification that's occurred between V2 and V3.
I've watched it before, by the way. This is
The level of integration is really unique for Rocket Engine. That comes from a lot of work among many engineers to consolidate the hardware. The effect of that is that it's actually a higher reliability design. So fewer parts is cheaper, faster to build. So that allows us to make a lighter vehicle, to make a more reliable vehicle, to overall just build a better rocket. Achieving full reusability of an engine like this is really something that people haven't done before. The goal is to get the engine to behave in a similar way to the engines on commercial airplanes. Frequently in interactions with people outside of SpaceX, the perception is that things far beyond what have ever been done before are impossible. Things being impossible is really to be determined by breaking laws of physics. We are not breaking laws of physics, we're just trying to leverage them as effectively as we can.
Prior attention to all B-19 operators, this is the final go, no go poll for today's operations. Our main objective today is a 10-engine static fighter.
Static fire is the culmination of the engineering process. We are bringing all of the pieces of the puzzle together, and we are lighting the engines. And if you make it through that, you have pretty good confidence that you're in a good position to go fly.
Aboard.
On LVN1, looks like we kicked out 2 combustors from
Abort
the apex
means
bank
fail.
being pelted.
Looks like we have to end time of 2.135 seconds.
We successfully lit all 10 engines. They were
Abort means
ramping up to
stop all
power.
everything and
Everything was
shut
looking
down.
good, stage and engines combined. However, there was a pad side abort called. So what that means is some sort of sensor tripped, and from there we command a fast shutdown.
It was a hard one, and especially since we had to drop all the engines afterwards, and thankfully 10 of them were salvageable, which is good.
We saw some data right after static fire that showed about half the engines had what looked like mechanical damage, basically as a result of the really fast shutdown. So we brought the booster back to Mega Bay. We then decided to remove all 10 engines from the booster so that we could troubleshoot and understand what's going on those 10 while still making progress on B-19 by backfilling engines from B-20.
All right, attention all operators on LVN1. Today's main objective is a 33 engine static fire on B-19. Okay, no-go poll coming up in 1 minute.
So we're doing our static fire today with all 33 engines.
Boy. There you go.
This is the final go-no-go poll for today's operations. Flight software?
Go.
AY?
Go.
Raptor?
Go.
Stage?
Go.
CE?
Go.
GC2?
Go.
GC1?
Go.
FC1?
Go.
Two has 10, 9, 8, 7, 6, 5, 4, 3, 2, mission.
Jesus Christ. Breath. Rust.
We kicked out early. All teams triage alerts. Prepare for offloading.
Today we aborted our second attempt of the B-19 full count static fire. We actually had another pad abort on the diverter. We made it through engine startup and then ultimately lost some of our sensors on one of the ramp manifolds. It basically said that the manifold pressure was lower than we believe that it probably was, and it kicked us out at T plus 1.88 seconds. It's just tough because there are some things that are hard to test ahead of time. So the diverter, you can test as much as you want, but you can't obviously test for what theoretical vibe and environment you're going to see when the engines are turned on.
Anytime that you walk into an operation where you want to turn on 33 of these enormously powerful engines and get them all to work together and walk away from it in one piece, that is a win.
I think every test is always a success, and we had a bunch of findings on the ground systems, the vehicle, and the engines that I think were really good to flag at this point, but definitely a bittersweet day.
We have this saying called "only the paranoid survive." The idea behind it is that there's an enormous amount of information and data that's coming to you, and if you can use that wisely, you can usually use that to figure out where things are going to go wrong in the future. And almost every time that we fail something or have something go awry, there were clues in previous data and previous operations that if you had known what to look for and had been good enough and paranoid enough to do so, could have found it there.
Oh, not this test. This was bad.
It's been 10 months since Massey's had the S-36 anomaly.
Yeah.
Ship 36 was a tough one. We had a CPV explode, and it not only took out the rocket, but it took out a lot of the test site infrastructure over at Massey's.
How do we go make sure if we have an anomaly again, the pad can take a beating and still survive?
Losing a rocket is one thing. We've got a production line for rockets, and we can go make more. Losing the physical infrastructure of the launch pad or the test site is very difficult because you need to go repair that over a period of many months before you can get back into testing. Now we have Massey's back online here. We've really, built this rocket from scratch, but we've also built the pad from scratch, so it's all kinds of new systems. This will be the first time that we bring together the pad and vehicle pieces to make sure that they all work.
Static fire vehicle is in pre-pad clear, about to get to our static fire pad cleared op state.
We run 60 seconds on ship because you get to see how the vehicle thermals all shake out and just general vehicle performance.
That if you can make it through that you're in a reasonable position to go fly.
Start up. Throttle up. Plus 10.
The journey of SpaceX is a journey to give humans access to the solar system and beyond, which is really the goal for Starship.
Plus 20.
The impact that this rocket is going to have on the world, I don't think most people can really comprehend the change it's going to have.
Plus 30.
This is such a wild ride. The highs are high, the lows are low, as we really work to get to ultimately launching people, which is going to be amazing.
Plus 40.
It is not impossible just because it's far beyond what has been done before. We've proved that time and time again.
Plus 50. Full duration.
All right.
Static fire vehicle.
Flight test of Starship version 3. This will be the first time that we are debuting this booster, this ship, the launch pad that you see there. And you can see people walking over my shoulder here as our colleagues are moving in masses to go watch this liftoff in just over 7.5 minutes from now. It's pretty exciting stuff.
It's pretty exciting, and as a reminder, we're only a mile and a half away here, so we are very close, about as close as you can be, and we're definitely expecting to feel it.
Sorry to interrupt you, Jake. Hi. Do we have a mic? Hello, for those of you that might not know.
How are you guys?
Welcome, Nikki. It's so nice to have you here.
It's a pleasure to be here.
Oh my gosh. What do you think the Barbs are going to say when they see you here at Starbase?
They better say all
Nikki
good things.
On the stream.
But they're going to be excited, and they're probably going to want to come themselves next time.
I mean, anybody can come and watch the launches. It's super accessible to the public, so we welcome that.
Okay, Barbs, come on down, because this is a lot of fun. I'm excited. Is it about to happen at any minute?
So you see that number right there in the top left corner, 6.5 minutes.
6 minutes left?
Yes.
Oh my gosh, but
Yes.
this is historic. This is a major moment, y'all.
Yeah,
it is.
Is this your first rocket launch that you've seen live?
Yes.
Wow.
Wow.
How do you feel?
Very, very excited. I'm happy it's a good day.
Oh,
Might
mic's
be
cut
like-
out.
I just noticed your shirt. You've got the right swag.
I love this shirt.
I feel
it's a
like
great shirt.
she
I have
might
one as well.
They might
And
have
it's a
got
great
her to do
name,
this.
Starship.
It's a bit.
I mean, how did you
off
predict
with
the
it,
future?
you know.
Starships are meant to fly.
I do not know.
He doesn't just turn up for no reason.
But
No
major
celebrity
shout
turns
out
up
to
for no
Elon.
reason.
Elon, thank you for everything that you're doing for humanity.
He's the man, for sure.
He did
Well,
start
thank
the
you so
company.
much.
All right, I'll see you guys
we want to
later.
watch the launch with you,
Okay, yeah.
so we'll take this back because this is too loud to take outside. Wow, what a moment. And with that, great timing. We're now at 5.5 minutes. This brings us into terminal count. Dan, man, the anticipation is certainly growing here in the lobby and out on the lawn. What is it like up there?
I'm just going to reset this quickly because I want to...
Out on the lawn, what is it like up there?
Yeah, we entirely full on ship on our main, still doing the header tanks, and we're looking well in excess of 90% on the booster, so we are looking good. Still not tracking any range, any weather issues today, not tracking any technical problems on the vehicle, on the launch pad, looking good for liftoff in just under 5 minutes. Once we're done with propellant loading on the booster, you have over 11.5 million pounds of that liquid methane, liquid oxygen on those 2 stages. After that, we have to essentially get the pad ready for launch. We'll do something called pushbacks, where all of those lines running underground from the propellant farm up to the vehicle, they're going to clear back. They're going to push all that propellant back into kind of the bunker area around the prop farm and just basically get the pad ready. We'll see the vehicles do their final thrust vector control checkouts. So when we snoop in, we should see the engines do kind of final wiggle checks. That's how we steer the rocket. We're going to do those at about T-minus 100 seconds, so a minute 40, and then once we pass the T-minus 40-second gate. If we do need to hold, that is still built in at T-minus 40 seconds. It's built into the countdown. We can pause if we need anything like those pushbacks to complete. If we need anything on the rocket to get ready, we can hold there. We'll only stop if we have an issue. Not currently tracking one. We have one item that might hold us up a little bit just based off of what we've seen in recent static fires, but that's typically only been hanging out for a couple of extra seconds.
All loading up live, ready to go.
And then once we pass T-minus 40 seconds, a lot of things will happen in rapid succession.
Yeah, that moment is called the QD, or Quick Disconnect Vent Gate. That's when we clear all the gas commodity lines that connect the pad to the vehicles. Both the ship and the booster configure their comm systems for flight and are rapidly running leak checks on gas and fluid tanks. The booster goes to internal power and its engines get their final priming for launch, while the ship's engines begin their ascent bleed profile and arms the automatic flight safety system.
Yeah, and once we pass T-minus 40 seconds, we still have the ability to rapidly recycle the count under certain conditions back to T-minus 40 seconds and hold there to assess what happened, review the data, and decide if we can proceed again all the way down to T0. We estimate we have around 5 minutes of hold time there. The flame diverter on pad 2 activates at around T-minus 17 seconds, and it enters what is essentially the point of no return at T-minus 10 seconds. And there's a chance we could recycle, but the closer we get to T-minus 10, the lower that chance becomes.
Oh, we'll cut my camera so you get to see the entire thing.
Coming up on 2 minutes, we have completed propellant loading
on
the booster.
It'll be fine.
Just shut down the fuel pump for loading onto the ship, so we're closing all of that out now. 2 minutes to go. One kind of exciting aspect to V3, we're not going to start the engines up in kind of different sets. All 33 of those Raptors going to turn on all at once. And you're going to see the booster move off the pad a whole lot quicker.
Once again, if you've just joined us, this is the first flight for version 3 of Starship. The ship, which is the upper part, the black part there at the top, the booster, which is the part below that, have been completely redesigned, as well as the launch pad that you see it sitting at, as well as the engines that power both the ship and the booster. Today's test flight is a massive step forward in our developmental program.
All right, and we're coming up here on T-minus 1 minute. So let's go to the pad and let the rocket do the talking as V3 fully comes alive.
T-minus 1 minute.
I'm going to cut the mic now, guys. I hope you enjoy it. See you in the next.
right, so we did hit the hold at T-minus 40. Again, this is something that is built into the timeline. Not surprising as we are doing this first flight off of pad 2. Sounds like we might already be clear. We held for a second just to make sure that the quick disconnect vents were basically ready for their final throwbacks. So we'll hang tight for a couple of seconds. I think we're about to reset, and the reset is in.
Ready to go.
Counting down. First flight of Starship V3. Psych, back to rapid recycle. All right, so hold here for a second. Looks like we're still managing some pressures in the ship quick disconnect. All right, still going to hang out for a couple of seconds here at T-minus 40. Again, not surprising. This is new vehicle, new pad, doing all these things for the very first time.
So nice.
Right now we are holding, looking at some pressures in the quick disconnect, and hold reset, and we're rolling.
Here we go. No, don't worry.
Flight directors, go for launch.
Back to rapid recycle, so we're going to hold at T-minus 40 again. Hang tight for a second, we'll see what tripped this last one. The reminder, we can hang out for quite a few minutes at T-minus 40 if we need the extra time. You're not actively loading propellant onto the vehicle anymore, so the main thing you're kind of keeping an eye on is all of the temperatures inside those propellant tanks.
I don't know where I bought it. I wonder it could go off. I want it to fly. Please? Fingers crossed.
All right, we're continuing to hang out here at T-minus 40. Team's taking a look right now at our diverter, so that water diverter underneath the system did trip a hold, but that basically just gives the team the chance to look at it, see if it's something that we need to troubleshoot in data or if it's something that we can clear this hold. So continuing to hang tight, T-minus 40 seconds. Starship and Super Heavy fully loaded on the pad. Clock is rolling.
Two eyes 30, flight directors, go for launch.
Oh, for God's sake! Oh.
And we kick back to rapid recycle again.
Something's not right. Something's not right.
Again, just a reminder, said it before, new pad, new rocket, learning new things about this hardware, performing in the flight environment. Taking a look at some of the sensors on the arm that manages the quick disconnect to the ship. The promise, we're not just trying to prolong the anticipation. Team's taking a look.
I should be recording this. It's not recording.
We've got a couple more minutes where we can hang out here. Again, it's not an unlimited time to pause at T-minus 40. We're keeping an eye on the propellant temperatures inside the vehicles. So we've got Probably about 3 minutes or so left of hold time.
With another recycle reset.
Team's taking a look at the hold that tripped on that arm for the quick disconnect on the tower.
Everything seems to be tripping. But the fuel has been recycled. You can tell the fuel has been recycled now. Yeah, they've got frozen stuff.
Continuing to hold, got a couple minutes to try and clear this issue.
Can't be this. I've been up all night. This is annoying. For me, this is going to be the most annoying. Because I've been waiting for 12 minutes. Nothing happens after restarting everything I have.
Still holding T-minus 40, still troubleshooting this issue. Probably got about a minute or a minute and a half left of hold time.
They got Nicki Minaj out and nothing. Oh, that would be funny. Is it software failure or is it a hardware failure? That's inside the link down, by the way. That's inside the second stage.
Flight control team confirmed, still working through the issue. Still have a short amount of hold time still remaining.
You get to the point where you're like, oh, this might not be working. Oh god, this is gonna be bad. This is not gonna be a good one, is it? Looks really nice there on the pad. Not gonna lie. Looks really nice. But everything's new, even in the entirety of the structure as well. So all the systems have to be removed. So it might take longer.
Still holding T-minus 40.
I swear to God, it's been over a minute now. I'm like, oh, it's not going to work. Maybe it won't disconnect and then it won't pull back, or maybe it's not going to pull back. It might be stuck. Because it has got stuck before. I did a test and it got stuck halfway. And then the new hydraulics for the chopsticks, they got stuck and then the hydraulics broke. So yeah, when you oil that thing, yeah, that was a good day.
All right, still continuing to hold here at T-minus 40. While we do that, the team's looking at temperatures of the propellant inside those tanks. We kind of check that against simulations that we've run in the past. There's some margin in those. We're still holding, no decision yet.
When it's like this, it's like you get very nervous because you know what you're going to expect.
Sounding like we have the fix in place. Hold reset, clock is rolling.
Please don't go back to 40 again.
We're back into rapid recycle.
Say that. Oh.
All right, we're back at our T-minus 40 hold. Standing by to see what tripped us this time.
No. I had to say that. I just had to. And now I'm cursed at that. One goes to me, one goes to her, one goes to Dixon.
All right, it is sounding like we are not going to be able to clear this issue in time today, so we are going to be standing down from a launch.
Yeah, it's an abort.
So if you're just now joining us, we got the vehicle totally loaded. We hit a couple of different holds as we work through that count. Again, new rocket, new pad. We're learning about a lot about these systems as we execute them for the first time, and we're not able to basically troubleshoot all of these issues in those final seconds to get to launch. But that essentially makes this a wet dress rehearsal. We were able to fully load the vehicles, and we're going to take the time now, figure out what tripped us up before launch, and then actually get into a flight tomorrow. We do have the ability to essentially rapidly recycle. We are expecting to be able to make another flight attempt tomorrow, but obviously stay tuned to our social media at SpaceX on X and our website, spacex.com, for updates. So no flight today. We will give it another try tomorrow.
Okay, that's not gone so well as I planned. Unfortunately, the rocket has aborted its launch, means it's not going to launch today. I've wasted half my fucking time. I am going to go and sleep now, but I will keep you updated. We'll reset the stream for tomorrow, so there you don't miss out. Always keep follow on Twitch or follow on YouTube. No, subscribe to YouTube. That's subscribe to my account. But I will repost everything tomorrow. Timer will be reset, and we will restart it. Okay, guys, I will go. So stay safe. Keep watching the rocket. Well, hang on. Keep in tune, and I'll see you all tomorrow.